poultry business is big business, with an annual income of over $3 billion from the sale of poultry and poultry products, and represents more than 14% of the total national farm income derived from animal products. Not so long ago, chickens lived on a few handfuls of grain, table scraps, and whatever else they could scratch from the ground. Today, commercial mixed feeds are scientifically compounded, completely mixed, uniform, palatable, and nutritive, promoting maximum performance and profit through improved growth and production, and saving time and labor required in mixing feeds on the farm. And breeders supply the excellent stock which has brought our chickens to their present high state of development. We've learned that we can't take out of a bird what has not been bred and fed into it. But between the initial start with fine stock and growth through scientific feeding to the final delivery of a marketable bird at a good profit stands the most important single element in the successful poultry business: management. Good management means wise management, backed by a vast amount of information available to the poultrymen of today. There are certain essentials which good management provides. It is considered good practice to allow 1 square foot per bird to avoid overcrowding. The birds should have easy access to good feed in hoppers protected from contamination, and clean water readily available on raised screen platforms to keep the floor and litter dry. Opinions vary greatly regarding proper ventilation, but all authorities agree that dryness is absolutely essential. A damp house can cause the birds discomfort, which might result in sickness, for dryness and good ventilation are closely related. While fresh air should be constantly supplied in sufficient amounts, drafts must be avoided. This is especially true in winter, when birds are kept confined week after week. The right litter is also highly controversial, but there are a few practices which are generally accepted as sound. The Bureau of Animal Industry of the United States Department of Agriculture suggests using a deep, highly absorbent litter, and adds that this method saves much labor and time and does not increase disease hazards. There is one point, however, which is not controversial. In fact, there is nothing more important in poultry production than starting clean and keeping clean. This applies to birds as well as to houses, equipment, and to the ground on which the birds may forage. The maintenance of good health marks the difference between profit and loss in the poultry business. Consider the loss to the poultry grower of a single bird. First, there is the original cost of the chick. Next, the cost of the feed the chick is consumed. Then there's the labor involved in feeding and caring for that bird. Add to this the average profit from the sale of a marketable bird, and we arrive at the grower's loss per chick. So it becomes obvious that the most important job the poultry grower has is the maintenance of the health of his flock. One of the most costly poultry diseases until recently was coccidiosis, which was so prevalent that growers in the past had come to accept a loss of 10 to 20 birds per hundred and the stunting of 8 to 10 more as a normal cost of doing business. While coccidiosis can occur at any age, the greatest danger of infection is in birds from 4 to 8 weeks old. Intestinal coccidiosis may occur during this period or later. It is generally accepted that all young birds reared on litter are exposed to this costly disease. Coccidiosis is caused by a microscopic parasite in a tiny egg-like cell, which is protected by a very tough covering. This cell, known as an oocyst, is passed in the droppings. In this stage, it is non-infective. But after about 2 days of moisture and warmth, significant changes begin to take place in the non-infective oocyst. 4 spores develop, each with 2 banana-shaped sporozoites, so that each oocyst, when matured, contains 8 sporozoites. The oocyst is now known as an infective oocyst. When it is swallowed by a chick, the infective oocyst passes down the warm, moist intestinal tract, where digestive juices of the bird dissolve the hard protective covering of the oocyst. The spores break through the weakened wall of the oocyst, and then the sporozoites escape from the spores. These released organisms invade the cells lining the ceca, or other parts of the intestine, depending on the species of parasite. Once inside the cell wall, the sporozoite develops into a rounded body enclosing a nucleus. This nucleus splits into two nuclei. These in turn split, and the process repeats until, when growth stops, a considerable number of nuclei have developed. Then, around each nucleus, a new organism, called a merozoite, forms, fitting with the others into a clump resembling the sections of an orange. These test chicks, injected with 25,000 oocysts, which is probably a great many more than they would normally pick up in the field, show very little change in appearance and appetite. Up to this time in the development of the parasite, about 3 days have elapsed. The intestines and ceca of this third-day chick look about normal, although small hemorrhages may sometimes be seen on the third day. Through the microscope, however, we see the rounded bodies formed in the cells by the invading sporozoites. And here in this cell is a further stage of the process, showing the orange-like cluster of merozoites before they break out to infect more cells. When these merozoites are liberated, they attack new cells, where the parasites go through the same cycle as before to form a second generation of merozoites. Now, when this greatly increased number of organisms breaks through the cells on about the 4th day, there is a good deal of tissue destruction which causes bleeding. The test chick on the 4th day has become listless and begins to show the typical ruffling of the feathers and failing appetite. During this stage, the birds may begin to die from loss of blood. The breakthrough of the merozoites from the cells caused the ceca to fill with blood and to swell considerably. The greatest number of deaths occur on the 5th day, and blood begins to appear in the droppings. Notice how the loss of blood has drained the normally rich red color of the comb. The reason for the bloody droppings may be seen here. The ceca are a little more swollen and have started to hemorrhage. This second generation of organisms invades many more cells. This time, however, in the case of cecal coccidiosis, the cycle completes itself in the formation of new oocysts, which will later be passed in the droppings to be picked up by other chicks, and thus start a new destructive cycle. Some of the birds still die on the 6th day, but those that survive the attack are immune and begin to improve. The blood in the ceca starts clotting, which in turn causes shrinking. The color of the walls of the ceca begin to return to normal. The microscope reveals great numbers of oocysts on this 6th day. When we realize that one parent cell is capable of producing over 500,000 oocysts, it's not difficult to understand how an entire flock may be infected by one single diseased bird. Late on this 6th day, these oocysts begin to pass in the droppings. Under farm conditions, the birds pick up the infective oocysts from such places as the litter, yards, dirty feeders, and waterers to spread the disease. The appearance of bloody droppings in the litter and the infected ceca are the telltale symptoms of cecal coccidiosis. Intestinal coccidiosis, on the other hand, is less easily recognized because other poultry diseases produce similar symptoms. There are many different species of coccidia which may produce intestinal coccidiosis. To save precious time and prevent serious losses, get a competent poultry pathologist who, with the aid of a microscope, can give a quick and accurate diagnosis. Don't guess or put too much reliance on your neighbor's guess. It may cost you most of your profit. The birds in the advanced stages of the disease seem to starve to death because of the destruction of the intestine where absorption occurs. Even with most careful management, it is almost impossible to completely rid the brooder house of all oocysts when cleaning and disinfecting, because all oocysts responsible for coccidiosis are exceptionally resistant to most of the common disinfectants. Just a few surviving parasites may infect an entire flock.